Section 24.2, Components of the Oceans. So the water in the oceans vary in density, and just like the changing density in rocks can generate currents inside of the Earth, changing density in Earth's oceans contributes to water currents as well. More dense water sinks, less dense water rises, and as they mix, it will stir up the oceans. Waves in oceans move in response to atmospheric effects like wind, as well as the motion due to water currents from the variable density of the Earth's oceans. The oceans can also be influenced by gravitational effects from the sun and the moon. The ocean floor is very, very deep. It's much deeper than there are mountains off of the surface. In fact, the ocean is one of the few regions we know very little about. For example, Mount Everest is about 9,000 meters above sea level, and the Marianas Trench, which is the deepest point in the Pacific Ocean, is about 11,000 meters below sea level. Ocean floors consist of ridges, basins, and trenches, and deep ocean basins account for 30% of Earth's surface. The region that connects the land to the oceans is what's known as the continental margin. It marks the boundary between the continent and the ocean. The components include the continental shelf, which is a submerged upper landward part of the margin. It's an extension of the continental crust. And then you have the continental slope, which marks the boundary between the continental and the oceanic crust. And here you see a steep drop off the bottom of the ocean to that more dense, thinner crust of the oceanic crust. And then at the bottom of the slope you find a region known as the continental rise, where you have sediment that collects as it falls down the slope from the continent. And here in this image you can see the coast and how that continental crust leads out to the continental shelf, and then the slope that occurs as it drops off, and then all the stuff that piles up at the bottom causes what's known as the continental rise over to the oceanic crust. And the region out in the oceans are the deep ocean basins. The water in the oceans, which we call seawater, is a complex solution of dissolved minerals, dissolved gases, and decomposing biological material. So chloride, sodium, sulfate, magnesium, calcium, and potassium make up 99% of the salts in the ocean. So we're very familiar with sodium chloride, it's table salt. But these are not the only types of salts that can occur. You can have potassium chloride, calcium chloride, for example. And you find these types of salts inside the ocean. Additionally, you find dissolved gases of carbon dioxide in the water as well. The level of salt in the ocean is known as salinity. On average, seawater has about 35 grams of salt dissolved for every 1,000 grams of water, or 35 parts per thousand. So, what that means is that seawater is about 96.5% water and about 3.5% salt. Fresh water can enter the oceans as runoff from groundwater, as precipitation, or as ice melting. It can leave the ocean through evaporation or during ice formation. When water evaporates from the oceans, the water evaporates before the salt does. This is why rain is not salty. And fresh water can leave the ocean during ice formation for a similar reason. Evaporation increases the salinity of seawater. Less water means more salt. So this is why oceans are saltier in warmer areas than they are in cooler areas.